So the purpose of this video is to check your work on your greenhouse effect review to prepare you for the quiz. And so early in this unit, we were studying what's happened to global temperatures. And the reason for that is, well, if we're really supposed to be concerned about climate change, is Earth's temperature really getting warmer? And we can see that the temperature of question one over time has changed a lot and that we're currently in a warmer period. Then the next thing we did was an experiment that you interpreted results. Remember, we had those 2-liter bottles, one covered, one uncovered. Now, this is an old graph I did by hand, but you can still see the same trend. This is a double line graph here, that the covered bottle gets warmer and stays warmer. And this is supposed to be showing you the way that the greenhouse effect operates. But then we learned that there's really no plastic wrap covering the planet. Instead, it's carbon dioxide that is trapping the heat. And so you watched Mrs. Shields and I play a game, and during that game, you notice that the infrared I misspoke. The visible light photons are the ones that are coming actually from space. Those are the ones that come from the sun, so come from space. And then what about the ones that we feel as heat? Those are the infrared photons. So number 3 should be visible light, number 4, infrared. Now our next question, number 5, asks, what's the main greenhouse gas that traps heat? And that is for sure carbon dioxide. That should be your answer to 5. You can use CO2 if you want. Now, I think question 6 is probably one of the trickiest, and that is, how can a carbon dioxide molecule kind of do double duty when it comes to trapping heat? And so here's the deal. One carbon dioxide can trap an infrared photon more than once, and that's in the game in round 3 when I got absorbed, my visible light became infrared, I headed up, I hit a carbon dioxide, I headed down, took another absorb card, I headed up, and I hit a different carbon dioxide. And so I made way more than 1 W on a turn, and it's because carbon dioxide can do double duty. That's why I always say a little carbon dioxide in our atmosphere goes a long way. But wait, is the greenhouse effect bad? And the answer to that is definitely no. Without the greenhouse effect, Earth would simply be too cold. Excuse me. Sorry about that. Okay, so now our next set of questions really asks us about, how do scientists know anything for sure about ancient temperatures? And the answer is here. Remember the stuff that they can know about ice from ice cores. The thickness of the layers tells us cold versus warm periods, and also carbon dioxide bubbles. So you need to have ice cores in your answer here. Now, question number 9 asks an important question about the relationship between Earth's warm periods and the amount of carbon dioxide that's in the atmosphere. And so we check out this set of graphs. Remember, this is showing temperature, this is showing carbon dioxide levels, and you really could almost put them on top of each other. So the way I worded it is to say that warm periods have high levels of carbon dioxide. You could have also said cold periods have low amounts of carbon dioxide. And then how do they know this CO2 from long ago? Remember, it's again ice cores. Okay, then you watched us do an experiment with different sources of CO2. So at this point in our unit, here's what we knew. We knew that Earth's atmosphere can trap heat. We knew that carbon dioxide levels were rising and that they connect to this. So where's this carbon dioxide coming from? And so we tested car exhaust, pure CO2 from a reaction gas, human breath, and then also the air around us, air from a pump. And so here's the right answers for question 10. The air around us actually has the least amount of carbon dioxide. There's really not very much at all. It's over 400 parts per million though, so that's a small percent. Next is our breath. Remember that we don't breathe out pure carbon dioxide. Most of what we breathe in and out is actually nitrogen. So it's just that 21% oxygen that's getting converted into carbon dioxide. But car exhaust was close in the color change to pure carbon dioxide. So that told us that burning fossil fuels was an issue. And so then we looked at this map. And these are the leaders around the world in terms of carbon dioxide production. And so what do we notice about these countries? The countries that make a lot of carbon dioxide in general have lots of industrialization, or you could say development. And so countries like India and China that have been on the increase lately are on the increase because their societies are becoming more developed. Keep in mind, though, that These two countries, even though they make a lot of carbon dioxide, their bubble's not nearly as big in the amount per person. We are one of those countries that's making way too much per person, way more than our fair share. Now, the final question, question 12, asks you to go back to your KWL chart from the first lesson in the unit and say some things you learned. So here's some things I hope that you've picked up: that greenhouse gases mean that they trap heat, that we're concerned about the level of carbon dioxide in our atmosphere because too much heat on our planet is not a winning part of the game when we think of the global warming game. I also hope that you're understanding that when you burn a fossil fuel, it's basically giving off pure carbon dioxide because those fossil fuels are made of carbon. Okay, so that should help you to study for your